This video is sponsored by Squarespace, the all-in-one platform to build a beautiful website. Oh look, another CG Matter tutorial. Maybe he's gonna teach us how to make some cool explosions. Nah, that's incorrect. Okay, maybe we'll learn how to take some footage, track it, and then put an explosion in our scene so that, no. Again, it's not what we're doing. Actually, this tutorial is just gonna be about teaching you how to handle your blue balls. So, unlike normal tracking, sphere tracking is something you can do completely manually. It takes a lot of time, a lot of keyframes, but you can really get some good results. And in fact, this is the technique I used back in my metaball video. In the basic workflow is you find some single colored ball, mark it with 2 dots, which we're going to need for tracking, film some footage of you fondling it, track the location, track the rotation, overlay this over your footage, key out the ball so your fingers are in the foreground, and composite everything together more nicely. And yeah, that's what we're going to be doing. It is a time-consuming process, but I'll show you some tricks to make it faster, and then I'm gonna trick shot you. I gotta say, this is some of my favorite background music, but anyways, at this point you've acquired yourself a blue ball, or more likely for my audience, a pair of blue balls, and you've added 2 markers and filmed your footage, making sure that they both always stay in frame. Now, the first thing we need to do is take our footage and convert it into an image sequence so that we don't have any frame rate issues. And to do this, just open up Blender, head over to the video editing workspace, import in your footage from whichever directory you saved it in, choose your project in and out points which will effectively trim your footage, and finally pick some output settings so that we can render out our image sequence. And now we're ready to actually begin tracking. Now it's time for us to do our location tracking, which means we're going to take our image sequence and try to match this motion with our sphere. And really the idea here is to find the center of the motion so that we can then simulate depth by changing the radius. In other words, our track isn't actually 3-dimensional, because instead of keyframing the depth, we're instead changing the size of our sphere, which means all the motion is actually contained in a single plane. And you might be thinking, okay, I guess I understand what he's saying, but I don't think that this will actually work. And that's a valid concern for someone who is stupid and wrong. So to do this, just open up a new Blender scene, set it up so you have the camera facing one axis, import in our image sequence as this camera's background, and add in a sphere set to shade smooth, which we're going to position and scale to match our sequence, and then make sure to keyframe both location and scale. We're then obviously going to go a couple frames down and update our sphere so it's matching, and then just add another keyframe. And we just kind of keep progressing like this, which yes, takes forever, but there are a couple tricks which will speed up this workflow. First of all, I recommend enabling X-ray with the alpha set to 0, which will let us only see the silhouette of the sphere, making the repositioning much easier. Also, you shouldn't be going 1 frame at a time to add your keyframes, because it's horribly inefficient and will most likely lead to super jittery results. Instead, you should try hopping every 20 frames or so to get our first pass, which we then refine by going back and filling in the midpoints in between to get our second pass, and you just keep progressing like this until you're happy with your current iteration. And believe me, this will save you a lot of time for this manual process, and then also for rotation tracking. So our sphere is now following the motion pretty closely, but you can see we're still missing the rotation component. And something like this is fine if we're replacing it with a plane sphere, but the moment we add any sort of texture, everything just falls apart. So clearly there's a need for us to do this. However, rotation tracking a plane sphere is nearly impossible, but luckily for us, we did add those 2 extra markers. So what we're going to do is create a new material, set it to show a checkerboard texture using UV coordinates. We now need to put our camera background into foreground so we can actually see our sequence. And with the coordinates set to local, just rotate the checkerboard hole so it's on one of our markers, and then rotate about the Z-axis until we have a checkerboard seam crossing our second marker, and finally add a keyframe for a rotation. And what we've done here is create a system that easily lets us visually line things up, and we just need to keep progressing down our footage. And again, remember that you should be putting down your keyframes optimally so you're going pass by pass instead of going frame by frame. We've got our footage, we've got our track sphere, and now the question is, how do we composite them together? And generally what we're going to be doing is first overlaying them together, then we're going to key out the ball, use this to put our fingers back into foreground, and finally we're going to bring back our original shading to add some realism. So step 1, how do we overlay? To do this, make sure to set our background to be transparent, head over to the compositing workspace with nodes enabled, and import in our original sequence so that we can overlay them using an alpha over node. Cool, we now have them overlaid, but you can see that the fingers are obstructed, and to fix this, like we talked about, we're going to need to key out the ball. And Blender has a bunch of different keying nodes we can use, but quite frankly I don't like using them, so instead we're going to do this manually. One way to do this is by taking our sequence and adding some pre-blur. We're then only going to look at the red channel for this, use a color ramp node to create a high contrast matte, throw in some post blur to add some softening, and invert our matte and use a math node to multiply this with our sphere alpha, which we're going to soften using dilation. Now let me ask you a question, are you a bit overwhelmed with all this compositing? Well, long story short, this node network is just meant to isolate our sphere without the fingers. So what we can do with this is use an another alpha overnode to bring our fingers back into the foreground, which means at this point we've integrated our render into the sequence, and the last step is just fixing the lighting. And how are we going to do this? Well, you can just again blur out the sequence, isolate the vibrancy channel, mix this with our node network with the mode set to multiply, and finally use one more alpha overnode to overlay this back in. And there you go, this is our compositing node network. Feature rich with controls for managing our shading, controls for managing our sphere matte, and controls for, I don't know. I hope you enjoyed this tutorial, found some value in it, because you're certainly not going to find any value in yourself.
So you now know how to do sphere tracking, but do you know how to create a beautiful website? No? Well, the sponsor for this video, Squarespace, has you covered. It has a super easy to use website builder, which in fact I used and currently use for my website, www.cgmatter.com. And the nice thing is you don't need to know any coding, because right off the bat you can get super cool looking results. And some of the features you might be interested in are analytics to check your website performance, email campaign so you can send your individual or brand message, and donation collection if you do something that people would want to donate for. And yeah, Squarespace is already super affordable, but to sweeten the deal a bit, if you go to my link in the description right now and use my coupon code, you're going to save 10% off your first purchase of a website or domain.